Hey guys, this is just going to be a quick recap of what we did on Wednesday. Just when we introduced probability, I'm just going to quick go over the exercises we did because it's going to be nice to reference in future when we get into deeper stuff. So we're going to start off with the coin flip example that we did. We said you're going to flip a coin 2 times, and we were wondering what the probability is of tails, getting 2 tails in a row. So one scenario that we could have, and we talked about just writing these out, you could get heads and then a heads. And you could also get heads and then a tails. You could get tails, then a heads, and you could get tails, then a tails. And these are the only possibilities if you flip a fair coin 2 times. The only one we wanted here was tails, and since there were 4 options, the probability of getting this would be 1 out of 4 because those are all equally likely, or 25%, also true. All right, and then we talked about how there's another way to look at this. We could use what we call a tree diagram. So we could start here before you've made any decisions and say when you flip a coin, you could either get heads or you could get tails. And that leaves you with another situation where you could also get a heads or a tails in either case. And when you do that, you have 4 endpoints here that all read. This would be your heads scenario. This would be your heads, tails. This is your tails, heads, and this would be tails. And again, this is the one we wanted. Clearly just 1 and 4. All right, so that was a really basic situation, and this is what we call a tree diagram. So we want to get used to seeing those because we're going to be using those a lot. All right, so that was the coin flip problem. We also had the ice cream cone. So we said there's an ice cream cone or an ice cream truck out front, and they have cones, ice cream, and toppings. You're picking one of each, and you do have to pick one of each. So the question that I asked was, what are our different combinations? How many combinations are there? And to do that, we used a tree diagram and said that before you make any decisions, the first thing you're going to have to do is pick between your cones, which are waffle, sugar, or dipped cones. But once you do that, you're then left with the question of what type of ice cream you want to use. There are 2 types. So you're either going to have chocolate or vanilla ice cream. So there are 2 more branches extending from each of those original 3 branches. And then from there, it gets a lot busier, and I'm not going to label them because it gets too messy. But from each of these, we would have 3 branches, one for rainbow sprinkles, one for chocolate sprinkles, and one for dirt. So you can see by the ends here, and I'll write out the first one, this would be waffle cone, chocolate, and rainbow sprinkles right here, right? And you could go ahead and write in all of these, this one, this one, this one, this one, this one, right? So you can see that we have 1 end, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 different possibilities. So there are 10 combinations. And the next question I asked was, what are the odds of getting a cone that has dirt on it if you're getting a random ice cream cone? And since each one of these groups is going to, of the 3, have 1 that has dirt, we have 1, 2, 3, 4, 5, 6 scenarios of those 18 that would have dirt on them. So 1/3 is your probability, or 33%. All right? So another example why a tree diagram is pretty useful. And then the final thing we did in class is we looked at a bag of marbles, and we said that in this bag of marbles, we've got 1 yellow marble, 2 blue marbles, 3 red, and 4 green marbles, for a total of 10 marbles. And then I asked, what is the probability of getting a blue marble? So the probability of a blue marble is going to be 2. There are 2 blue marbles of the 10 in the bag, which is 1/5, or 20%. And then over the course of the day, we did this study by experimenting, and we ended up getting 12 out of 69 marbles pulled, which ended up being 17%. So the actual probability here was 17%, which is close to 20%, but not identical. And we talked about the fact that if we were to keep completing this study over and over again with many, many people and many trials, we should get closer and closer to that 20% mark. The probability of a yellow marble is going to be 1 out of 10 because there is only 1 yellow marble in there, or 10% And then as we repeated this study all day long, we got 8 out of 69 people, which came out to 12%. So that one, a little bit closer to what we actually predicted. And then lastly, what is the probability of getting a blue or yellow marble? Well, there are 3 that fit that criteria of these 10, so 30%. And then through experimentation all day, we ended up getting 29% in our studies. So we got to see kind of the experimental versus the theoretical probabilities of these. All right, and let me just label those. This would be experiment. The red would be our theoretical probability. And the blue was our experimental. So if you missed class or you were there and you just don't quite remember everything, this is just an overview of what happened on Wednesday, the day we got back from break, all right? We're going to be diving into some more deep stuff, probability-wise, over the next few days, so this foundation is going to be pretty important. All right, well, hope it helps. I'll see you guys tomorrow.